In this demonstration, I'll show you how to derive the quadratic formula. The quadratic formula is shown here, and below it is the quadratic equation in standard form. A quadratic equation is in standard form if it looks like this, where you have ax squared plus bx plus c. In order to derive this formula, you'll need to know how to complete the square, and I do have a video dedicated to completing the square, which takes an equation that's in standard form to an equation that is in vertex form. When it comes to completing the square, this term, the a term, needs to have this coefficient vacant. So you can't have a number in front of the x squared. So in our case, we have an a, and to get rid of that a, we have to divide the whole equation by a. Let me demonstrate what I mean. So dividing the left side and the right side by a gives me 0 on the left side, and on the right side, x squared plus b over ax plus c over a. The next thing that I have to do is identify my b term. This is my b term, and you're going to take the coefficients of that b term, which happen to be b over a, and you're going to divide them by 2. And by dividing this term by 2, we end up with b over 2a. Now also, you have to take this term and square it. So if we square this term, we end up with b squared over 4a squared. Now be mindful that a, b, and c represent numbers. So b and a, in this case, would represent a number. We're going to take this term now and incorporate it into our equation. Here's how. So 0 is equal to x squared plus b over ax. This part hasn't changed. And I'm going to add this part to my formula and also subtract it from my formula. So I'm going to add it, and then I'm going to subtract it. So this part remains the way it is, subtracting b squared over 4a squared. And you have to add and subtract the same term, otherwise you're changing the equation. The next thing that you have to do is put brackets around the first 3 terms. Now keep in mind what we're doing here is we're completing the square. So I'm going to put brackets around the first 3 terms, and what this leads to is a trinomial that is factorable. I mean, take a look. You can find 2 numbers that will multiply to this, and those same 2 numbers will add to this. Can you think of those 2 numbers? Well, think of it this way. b over 2a times b over 2a will give you b squared over 4a squared. And similarly, b over 2a plus b over 2a will equal to 2b over 2a. Notice that when you add 2 fractions, you keep the denominator the same, and you simply add the numerators. So the 2's cancel out, leaving you with this coefficient, b over a. So since these 3 terms are factorable, we can write it out in factored form. X plus b over 2a, which is that first number, and also x plus b over 2a again. Those are the 2 numbers that we found happen to multiply and add to the last and middle term. And I'm going to write this part out the way it is. That hasn't changed. Now these 2 are identical. So instead of writing them out like that, we can actually write them out as x plus b over 2a to the power of 2. The next thing that I will do is solve for x. And this is where the hard part comes in. You technically have to isolate for this variable by removing every other term to the other side. Now to make life easier, I'm going to combine these 2 terms, and to combine these 2 fractions, I need to find a common denominator. Notice that the denominators are not the same. To make this a into 4a squared, I'm going to multiply the bottom of this term by 4a, and what you do to the bottom, you do to the top. Which leads me to 0. This part remains the way it is. And this part becomes 4ac over 4a squared. And this part stays the way it is. Since the denominators are the same, we can leave the denominators the way they are and simply concentrate on the numerators. So we end up with plus 4ac minus b squared over 4a squared. And this part remains the way it is, so I'm going to rewrite it. Next, I'll solve for my x by bringing this whole expression over. And if I do that, I end up with minus 4ac minus b squared over 4a squared is equal to x plus b over 2a squared. Now before I go any further, I do want to distribute this negative to the two terms at the top. Remember, this negative means -1, and -1 can be represented as -1 over 1. So we're multiplying -1 over 1 to this, which will give us 4ac, which is now minus 4ac, plus b squared over 4a squared. And on the right side, what I'll do is square root both sides, because notice that this x is being surrounded in brackets by this power of 2. So to get rid of this power of 2, I'm going to need to square root both sides. And this gives me, on the right side, x plus b over 2a. And on the left side, we have the square root of this expression. Let's continue. Now what we have to do is bring this b over 2a to the left side. And if we do that, here's what happens. Instead of rewriting everything, I'm just going to take this b over 2a and bring it here. And of course, if you bring this term, it becomes negative. I'm going to erase this on the right side. So now to combine the terms on the left side, I'm going to use one of the law of exponents, which says that if you have a quotient, let's say a over b, and it is being square rooted, each of the terms will get the square root. So the top term will get the square root, and so will the bottom term. Let me show you what I mean. The top part becomes b squared minus 4ac. And notice that I've just switched the positioning only so that it mirrors what this one looks like at the top. And you can do that mathematically, that's valid. And that is being square rooted. And at the bottom, you have the square root of 4a squared. Now, the square root of 4a squared is actually 2a. Minus b over 2a is equal to x. Now this is looking more and more like the quadratic formula. Notice that the denominators are the same. That means the numerators, this part and this part, can be combined. Combining them, we end up with minus b plus the square root of b squared over 4ac all over 2a is equal to x. That is the quadratic formula, but you're probably wondering, why does the quadratic formula have a plus and a minus? Now to answer that question, anytime you square root a number, there's always a plus and a minus version that could represent the answer. For example, if I took the square root of 25, you can get plus minus 5, because -5 times -5 will give you 25, and so will +5 and +5. Therefore, it can be plus or minus. That is how to derive the quadratic formula. Just to give you a full view, this is all the work it takes.